Hey guys, in this video we will be going over absolute value equations. So the absolute value of a number is its distance from 0 on a number line, where distance is a positive value. So let's visualize this using a number line. Consider the absolute value of 3. 3 is positioned here on the number line, and its distance from 0 is 3 units. Therefore, the absolute value of 3 is just 3. The same thing for the absolute value of negative 3. Negative 3 is positioned here on a number line, and its distance from 0 is also 3 units. Therefore, the absolute value of negative 3 is just 3. Okay, so some examples of absolute value equations include the following. And we'll go over how we can solve equations as such. So for our first example, we want to solve the equation for x. Let's try to solve this by inspection. The solution set will contain all numbers that are a distance of 3 units from 0 on a number line. So using a number line, we see that the number 3 has a distance of 3 units from 0. And the number negative 3 also has a distance of 3 units from 0. Therefore, we have two solutions. X is 3 and negative 3. Okay, so let's try another example. For this, we need to ask ourselves what value or values of x has a distance of negative 2 units from 0. So this is actually not possible since distance cannot be negative. The absolute value of a number is never negative, therefore the solution set is no solution, which is the same as the empty set. For example 3, again we need to figure out what value or values have a distance of 0 units from 0. There's only one solution for this, and that is 0 itself. Alright, so let's write down some properties we've learned from these examples. So to solve the absolute value of something, say A, equals something else, say B, if B is positive, then just simply solve A equals B or A equals negative B without the absolute values, just like example 1. We most likely have two solutions. If B is negative, then we actually have no solution, just like example 2. Then if B is 0, we just solve A equals 0 without the absolute values, and we'll have one solution. By the way, this A can be either a single variable or an expression. So let's try an example with A being an expression this time. We wish to solve the following absolute value equation for W. Since the side opposite to the absolute value is a positive number, we can just use our first property to solve this. So we break this up into two problems. We take the inside and set it equal to 7, and we also take the inside and set it equal to negative 7. For the first equation, we start with subtracting 3 from both sides. Canceling out the 3's, we get 5w equals 4. We then divide both sides by 5, reduce, and we're left with w equals 4 over 5. Now we have our variable isolated. And for the other equation, we also subtract 3 from both sides, and we're left with 5w equals negative 7 minus 3, which is negative 10. Then we divide both sides by 5, reduce, and we're left with w equals negative 10 divided by 5, which is negative 2. And now we have our variable isolated. Therefore, our solutions are 4 over 5 and negative 2. So now let's check this. First, we'll substitute 4 over 5 for w into our equation and see if we get a true statement. We can simplify the inside of our absolute value and reduce the 5 over 5. We're left with the absolute value of 4 plus 3 on the left. Combine the 4 and the 3 and we have the absolute value of 7. Then taking the absolute value of 7, we have 7 equals 7, which is a true statement. Therefore, 4/5 is definitely a solution. Now we'll check our other solution. We substitute -2 into our equation for w this time. So simplifying, we get the absolute value of -10 plus 3 on the left. This gives us the absolute value of -7. And then taking the absolute value of -7, we have 7 equals 7, which is also a true statement. Okay, let's try another example. This time, we have to first isolate our absolute value expression before we use our absolute value properties. So we will need to subtract 5 from both sides of the equation. This cancels out the 5 on the left side. So now we've isolated our absolute value. Now we can apply our absolute value properties. So since the side opposite to the absolute value is positive, we can split this up into two equations. One with the inside equal to 1, and the other with the inside equal to -1. For the first equation, we add 1 to both sides and simplify. Then we divide both sides by 2, and this reduces to x equals 2 divided by 2, which is 1. For the other equation, we also add 1 to both sides. Simplifying, we get 2x equals 0. Then we divide both sides by 2, and we get x is equal to 0. And that's it. So our solutions are 1 and 0. So sometimes we will want to solve equations with absolute values on both sides. So two absolute value expressions are equal when the expression inside the absolute value bars are equal to or opposites of each other. So for example, absolute value of 2 is the same as absolute value of 2. And we have the expressions on the inside the same. Also, absolute value of -2 is equal to absolute value of -2. And we also have the expressions on the inside the same. And absolute value of 2 is also equal to absolute value of -2, which is true. And we have the expressions on the inside as opposites. Let's write down this property. So to solve absolute value of A equal to absolute value of B, again, the inside of the absolute value bars can either be a single variable or an expression. We solve A equals B or A equals opposite B without the absolute values. We'll go over an example to make sense of this. So for example 6, we have two absolute values equal to each other, and we wish to solve for x. So we're going to take the inside of the absolute values and set them equal to each other, and then take the inside of the absolute values again, and then set them opposite to each other. So 5x minus 8 becomes -5x plus 8. These are the two equations we will solve. So for the first equation, we need to get the variable on one side, so we can subtract 3x from both sides. Simplifying, we get 2 equals 5x minus 3x, which is 2x minus 8. Next, we will add a to both sides and simplify. And then our last step is to divide both sides by 2. We have 5 equals x. For the other equation, to get x by itself, we can add 5x to both sides. So simplifying, we get 3x plus 5x, which is 8x, plus 2 equals 8. Next, we subtract 2 from both sides and simplify. And then we divide both sides by 8. We can simplify the right side by dividing out the common factor of 2, so we're left with x equals 3/4. So our solutions are 5 and 3/4.